What's up everyone, welcome to part 3 of my Jupyter Notebooks tutorial series, and in this one I'm going to show you how to animate your plots. So the reason why I'm doing this is because there's not a lot of good information online, and the examples that do exist make it sound a lot more complicated than it really is. So in this video I'm going to show you how to make the plot that you see right here. So let's get started. So I'm going to start by coming to my Jupyter homepage and selecting New and Python Default. So to start, what I'm going to do is copy a function that I used in my Convolution Basics tutorial. So if you haven't seen that one, I'll put a link in the description. But basically I have a function for a rectangle. So what I'll do is copy that just right into my first cell. And to do a quick recap, what this does is you pass in the number of points you want, which is X, and then the width of the rectangle. And what this does will give you a NumPy array that's either 0 or 1, and it's 1 for the width B. So it'll be a little more clear when I show a plot of it later. So we'll save and run that cell. And then the next thing I'm going to do is, in order to do the animation, what we do is instead of using the matplotlib inline magic function, we're going to use a slightly different version called matplotlib notebook. And what notebook does is it makes the matplotlib plot live. So it has the tools to zoom, pan, move back to home, and that toolbar that you're probably used to seeing. So the notebook kind of makes it live, whereas inline gives you a static plot. So now let's proceed with our other imports. So we're gonna need to import matplotlib.pyplot as plt, and then from matplotlib.animation import func animation. Cool. So let's just bring that up, and then let's define some constants. So we'll just say constants and our x array. So what I like to do is do pi is equal to np.pi, and you'll saw that I imported numpy above here. So we got pi, and then what I'm going to do is define this thing called length, set that equal to 2000. So that's the number of points we're going to be using. So, and then we'll define our x variable as np.linspace, and we'll do from -1 to 1 with length number of points. Now let's set up our plotting. So what I mean by that is we're going to create our matplotlib axes. So if you saw in our last video, we just used plt plot and it created the figure. Well, this time we're going to create a figure and axes object. So the way we do that is we'll do fig and then ax1 comma ax2, and we're going to set that equal to plt.subplots. And because we gave it 2 axes, we need to specify the number 2. And then we need to, I'm also going to give it the fig size. So we'll say fig size is equal to, we'll do 12 by 6, because it's going to be 2 axes stacked on top of each other. And then what I'm going to do is sort of initialize the plots. So what I mean by that is create a plot object. So the first one, I'm going to call it sync with a comma, and set that equal to ax1.plot. And then it doesn't really matter what you put here, but we just need something. This is not too important what you're plotting, but we'll just make it x and then np sine x, and then we'll make it a blue line. And the next one I'm going to just call it box. And we're going to set that basically equal to the exact same thing. So I'm just going to copy paste and make this a 2, and I'm going to make it a red line. Cool. So next thing I want to do is define a function that I'm going to call animate. So we're going to do def animate, and it's going to take in the the width of our box. So that's going to be the input. And let's see, it's going to be, let's add a little doc string to explain what we're going to do. So let's say this function, it's going to gets called by that func animation, the one we imported, and then each time called, it will replot with a different width b. So it's going to get called in a loop, and then it's going to pass a new width over and over again. So the width will grow and then shrink, just like you saw in the introduction. So like we said, b is, we'll say rect width, and then we'll say return, and let's say we'll do the sync function, which is our y data. So the sync y data, and then the box y data. Cool. So that'll be our doc string. Oops, didn't mean to run it. So now let's define our function. So we're gonna call the box f, little f. So that's gonna be our rect function, and it's gonna be the length of our x variable, which had 200 points or 2,000 points from -1 to +1, and it's gonna be length or width b. So then what we need to do is we need to set the y data for the box. So our box was the plot object for axes 2. So now what we're going to do is box.set y data, and we're going to set it equal to f. So basically our box is going to be the second plot, ax2, and then our sync function is going to be ax1, or the sync. So moving on, we'll do capital F is equal to our sync function, which is b, divided by the length, and then it's going to be times np.sign, and it's going to be x times b divided by 2, and then that's all going to be divided by x times b divided by 2. And the spaces are keeping everything PEP8. So next what we're going to do is the same thing, is we're going to set the y data for sync. So we're going to do set y data, and it's going to be capital F. Cool. So next thing I want to do is define another function, and this one we're going to call init. And it's not going to take anything in, but basically what it's going to do is just initialize the figure. So what I mean by that is we're going to use this to set our x and y limits and maybe add some extra features to the plot, something that you set once, as opposed to things that we're going to set in a loop. So what we want to put in here is, I'm just going to add some of the limits. So ax1, we're going to set the y lim, and we're going to go from minus, actually no, for ax1 we're not going to set the y lim in here. So for ax2 we're going to set the y lim, and we're going to go from minus 0.2 to positive 1.1. So ax2 is the box, so the height's not going to change for the box, but you can see that for our sync function, the height is going to change. So that's going to be something we're going to set in here. So we'll do that later. And then we can set the x lim for both of them here, because that's not going to change. So for the ax1, we're going to go from minus 0.25 to positive 2.25. And then for ax2, we're going to set the x lim, and that's going to be from minus 1 to 1. Oops. Minus 1 to 1. Cool. And then I'm also going to add this AXH line. So it's just a horizontal line at the origin. So it'll be at 0. We'll do the color is equal to black. And we'll do the line width equal to 1. And then I'm going to do the same thing for AX2. So I'll just copy paste, make that a 2. Cool. And then I'm also going to update the font size. So I'm going to do Pt.3 params, and then it's update, and then we feed it the dictionary with the text font dot size, and I'm going to do 14 for this one. Cool. And then finally, we just need to return the sink and the box. Awesome. So that's our init function. So finally, what I want to do is we have to call our func animation function that we imported. And the way it works is, first, what I want to do is define a variable that has all the widths that we want to plot. So what I'm going to do is define a variable called step, and this is going to be the step size of the widths. So I'm going to set it equal to 10, and then I'm going to create a variable called steps. First thing I'm going to do is do np.arrange, and then we'll go from 10 to 1000, and it will be in steps of 10, so we'll call it step. And then now we need to create our animation object, so we'll call it Annie, and we'll set it equal to func animation. And then next we need to give it our figure object, which is fig. Then we need to give it our animate function. Then we need to give it the input for the animate function. In this case, it's steps. So this is what's gonna go in. So steps are basically the widths. Remember, we're gonna input B, which is our widths, which is the same as steps. Next, we're gonna call our init function. So init func is going to be equal to init, and then we need to set our interval. So this is a amount of time between each slide or each frame in the animation. So think of it as a video, and it's how much time between each frame in the video. So to make it kind of fast, I'm going to do interval is equal to 50, and then there's this thing called blit. And we're going to set this equal to true. So I forget exactly what blit is, but the way I understand it is that if there's something in the plot that's not changing, it won't replot it or redraw it. So I'm pretty sure it's always something you want to set equal to true. So in the examples, it's always set to true. So we're going to stick with that. So finally, we're going to do plt.show. And this should be enough to get our plot animated. So cross your fingers, let's run it. And I've got a problem with this, so, oh, I forgot the comma. Now we run it, and cool. So now you can see we've got some basic animation. So the box is growing and the sync function is getting more narrow. And if you watch my convolution series where we talked about the Fourier transform, you'll see why that is. So if you're interested, go check that video out. I'll link in the description. So this is our starting point for the animation plot. And if you noticed in the intro of the video, it was a little bit different. You saw that the height we held it constant. We had moving labels here, and we had a height that was updating on the fly. So let's make this thing a little bit fancier. And just to show you that the difference between the inline and the notebook magic function for matplotlib, you can see here we can resize this thing on the fly. We have the toolbars here to go home, go back and forth, pan, zoom, and save. And then if we want to freeze this thing, there's this little button right here. You just click it and it basically turns it into the inline version, so like the static or frozen version. So let's get started with making this thing look a little bit nicer. So if you noticed in the beginning, we saw the box grow to a certain width and then it started to decrease. Whereas this one, if I restart it, it grows to its maximum width, and then boom, it goes back to its smallest width. So I want it to sort of bounce back and forth. So the way we do that is we need to change our steps array. So what I'm going to do is pause this, And then instead of making steps equal to this, what I'm gonna do is I'm gonna basically copy this bit here. Let's just add a comma. And then I'm gonna do the opposite. So it's gonna be the same array, just backwards. So I'm gonna go from 10,000 to 10, and I'm gonna do it in the reverse direction. So the way we do that is we make it a minus steps. So we'll just do -1 times steps. And then we need to concatenate or stack these two arrays together. So the way I do that is np.append, and then we're just gonna append these together. So append, the NumPy version of append is you take two arrays and you feed it, and then it stacks them one after another. So now, just to show you, when we run this, it's gonna grow to its maximum size, and then it should just turn back around and shrink again. Cool. So the next thing I want to do was, I had in the intro, I had the labels b/2 or -b/2 and +b/2, and they would actually move with the box. So I want to do that feature. So the way I did that was, I'm using the XTicks and the XTicks labels. So if you saw my first video on plotting, you saw that I showed you how to do XTicks and XTicks labels. But because we're using axes, it's a little bit different. So what I'm going to do is just copy paste the code that I did and walk you through it. So for AX2, this is the code. And because this is something that's going to be updated every frame, it's going to need to go in my animate function. So I'm just going to come down here and paste this here. So it's plt.setP. And what I do is I specify the axes, in this case axes 2, and then we can specify both the Y ticks and the X ticks. So X ticks are going to be something that are static because the height of the box never changes. And I'm just going to set it equal to 0 and 1. That way, we don't need all these little points here. It just clutters the plot. So I just want to show 0 and 1. And then what I'm going to do is I define my X ticks. So I say X ticks is equal to -1, and then we're going to have a -b/2 and then a +b/2. And you can see that I'm using this b/length. And what that does is that's going to be updating in the loop, and that allows it to move with the width of the box. And then these are the actual coordinates, and then these are our labels. So this time I'm not using LaTeX because it's hard to get everything to look correctly with LaTeX. And so I just skipped it for this one, and I think it looks okay. So now when I run this, you can see I've got b/2 actually moving with the box. So we've got -b/2 and +b/2. So just something to make your plot look a little nicer, a little cooler and fancier. Another thing I did in the intro version was the height of the sync function was actually, it looked like it wasn't constant. So what was happening was the y-axis was getting rescaled on each one. So, and I also had a label that said b is equal to this, which basically is showing what the height of this thing is. So the way I did that, I'm just going to copy and paste the setup for that one. And it's basically similar to what I did for the box. It's going to be something that'll be updated in a loop. So I'm going to put it in my animate function, and it's basically a similar setup. So it's plt.setP. Our axes is going to be AX1. Our XTicks are going to be static. So we're just going to label it as -1/4 to +1/4, just to get rid of these extra points. Yeah, so one tip for your plots, you don't want to clutter it with too much stuff. Anything you show on your plot should be something that has some meaning for being there. So there's no point in having 5 labels here. We should just have like maybe 0 and the max and min values. And the rest of these points are just clutter. Same thing I did with here. If you compare this plot to this one, you can see there's less labels, and we're just labeling the key points. We could even get away with not showing this -1 or +1, but if we compare the y-axis, I think it's better with just 2 points, just the key points, the bottom and the top of the box, instead of multiple points. So that's what I'm doing with the X axes. I'm just showing 2 points, just the max and the min. And then for the Y ticks, we're going to show 0. And then we're going to show the maximum value of our sync function. And then the label is going to be 0 for the 0 point. And then we're going to plot the height b. So it's going to be b equals, and it's going to be, we're using some formatting. So this formatting says, take this number, b over length, and write it as 2 decimals. So the colon indicates that we're going to format a number. The F means that it's going to be a float, and the .2 means to display 2 decimal points. So let's go ahead and run this thing. And you can see that I've got the b equals, but we need to rescale our axes each frame. So we're going to have to use the set y limbs, and this one is going to be something that needs to be done in a loop. So the way I do that is I'm going to go up here, I'm going to do ax1.set ylim, and we're going to do np.minimum of f, and then np.max of f. So now when we run this thing, you can see that it's always going from the min and max of the plot, and it sort of looks like it's frozen in height, but you can see that this b is updating. So you can see that the height's growing as the box gets wider, and then it gets smaller as the box gets narrower. Cool. So I think that's going to do it for this video. Like before, I'm going to post this to my GitHub so you have access to it, and I'll go through and comment the code a little bit to make it more user-friendly for you to pick it up and go and customize it however you like. So yeah, that's going to be it. Just to give you guys an example of how to do animation in Jupyter, because like I said, the material online is not very helpful and it's a bit confusing, and it's actually a really simple thing to do. So hopefully this will get you guys started and you'll be able to, make some really cool plots. So if you have any questions, feel free to ask in the comments below. Also check out the Facebook group where you can comment or even contact me directly for help. If there's something else that you'd like to see with Jupyter Notebooks, you have any ideas or requests, please let me know. I'll be more than happy to make a video on it. And yeah, so if you like the video, give it a like. And if you like the content you're seeing, then hit that subscribe button. There's gonna be more videos to come. So thanks guys, see ya.